My name is Martin Husum. I'm a developer at .NET. So today I'll be presenting uh, automating data validation for better BIM compliance. So the agenda for today, I'll have a short intro, go through some prerequisites, how the thing all started, the solution we came up with, some future potential and takeaways, and then I'll open for some questions. So the intro, again, short about me. My name is Martin Husum. I'm 26 years old, and I'm from Tønsberg in Norway, which is about 1.5 hours south of Oslo. I'm a developer at .NET, and .NET is Norway's transmission system operator. I like 3D models. I have a bachelor's degree in mechanical engineering, so I've worked a fair bit with Autodesk Inventor and CAD. And now I'm working with BIM. After my bachelor's, I started a year study of informatics and programming and got a job offer pretty much right after I started. So I only finished one semester. And today I have, I have 2 years of work experience at .NET. So why does this topic matters? Validation, and specifically IDS and IFC validation, is for us an important part of checking the status of our 3D models or BIM models. We outsource the modeling and design of these BIM models, so we need to be ensure that the quality and the compliance are up to par with the specifications we agreed upon before. The automation part is self-explanatory in a way. A BIM model can have several hundred thousands objects, and I don't wish that job for anyone to go through manually. And it's also really expensive to fix data errors when you really want to start building. So we want to find these errors as soon as possible and fix them. So we're ready to build when we want to build. The goal of the app, I'll be saying app and validator, they are the same. But the goal is to check the models we receive. And also to have a report and have some backup claim if something is wrong and we want the consultants to fix it. We also want to create a culture of the consultants checking the models before they deliver them to us. I have an analogy on the whole situation as I see it. So .NET is the teacher who's giving out homework to the students, which are the consultant firms. We give out homework, and the consultants or the students write down and deliver something back to us. What we have been doing is just looking to see if there's something there, and it always is, but we haven't really gone into the details and checked that what we really need is there. So that's what we're doing now. We're going through the data of our BIM models we receive and double checking that what we need is in the models. So some prerequisites, who really is .NET and what is a transmission system operator. So what we are responsible for building, operating and maintaining the Norwegian power system. We're in a way the high voltage highway of Norway. We deal with mostly 300 and 420 kilovolts. And as you can see in the logo, and especially on the picture on the right, So the slogan, our slogan directly translated is the green artery, which you can see in both of those. So how we work with BIM, so we aren't the typical, we don't have the typical buildings, but we have transformer stations. I'll show you a picture of those on the next slide. So we don't really have BIM models of the transmission towers you see in the pictures, but they're too cool pictures not to show. So we outsource the design part of the BIM models, but what we do in-house is the planning of what we need it, where we need it, and how we're going to make it happen. So firstly, the picture. This is an outdated BIM model of some of the electrical components in a transformer station. And we deal with these, they are on the IFC format. IFC is an open format, which is developed and maintained by Building Smart. The check we do is an IFC IDS validation. So the IDS is an information delivery specification. It's a human and machine readable file that where you define requirements to the data in the IFC file, so the 3D BIM model. For example, that every door should have a fire rating. In this specific example, the entity IFC project should have a name. The name should be 5 digits or contain 5 digits, and it should match 10,324. So you can go and be really specific of the data you want on specific IFC classes or entities. We also have BCF, and all of these 3 file formats are from Building Smart. BCF is BIM collaboration format. It's an issue format allowing for communication through an IFC model. The yellow dots you see on the picture are unique issues. So you can see here we have a lot of issues with our insulator discs. The process we want, or the workflow we want to have. So if we start on the top left, we need to define some requirements, what we want in our BIM model. The requirements should then be written in an IDS. And when we have the requirements, we can start producing data, which is the BIM model or the IFC. When you're happy with the IFC so far, or just want to check how the status is, you can do an IFC IDS check. I've never really seen a proper IDS IFC check with no errors. So you will most definitely get some BCFs, but that's just nice. You can import them and fix the issues. And then this process repeats until you're happy with the IFC, and then deliver it. So how it all started. When I started here at Statnet for around 2 years ago, we were, me and one other were the first 2 to really programmatically look into a BIM model, and we found a lot of errors. Data errors. We tried the APS Hubs browser tutorial and tried making some custom filters. So we tried to color a model based on a property and the value of that property. And there was a lot of error, a lot of objects that didn't really change colors. So we found out pretty early that the data wasn't really that good. Then almost a year later, I had 2 weeks during summer break where I had bit offset summer break. So I was pretty much alone, well, from a team, and a colleague tipped me off and wanted me to test IFC OpenShell, and specific the IFC tester package. So I was tinkering with these packages, and after 2 weeks, when the other guys came back, we thought that this has potential and wanted to test it further. So by following a tutorial and doing some minor changes, this was the first draft. It's a web application, and if we zoom in on the left side here, it consists of a model loader. So you're supposed to upload an IFC model and an IDS loader. So here you can upload your IDS for the specific project or file, or you could choose an IDS from a list. Okay, sorry about the lighting here. So here in the yellow boxes on the left, I've uploaded an IFC and an IDS. Then it appears a validate button. If we click on that button, it renders a HTML report in the page. If I zoom in on this, we can see at the top here that we have done 160 checks with 22% that passed. Not really a perfect result, but we can see that we have some work to do. This was the first draft, and it was too many clicks. You had to bring your own IFC. For the most part, you would in most cases you would bring your own IDS as well. And those people who would utilize this program wouldn't really be interested in having yet another solution to work with. So I added a V2 behind the name. With the new game plan, you're not really supposed to study this. There are no secrets, and this was just really meant to show that we had to rework what we had. So this is a really simplified illustration of how the app works today. If we follow the numbers, we have an initiator that sends that starts the validator, says that okay, let's get to work. On point number 2, the validator connects to ACC, goes into a project, finds the right files to validate, downloads them, validate them, and then create reports. The reports are PDF and BCF. And then when those are created, those are uploaded back to the same project. The benefit with this is that the user only needs to interact with ACC as they already do. And everything is taken care of for them. So before we go in a deeper dive of how the app actually works, this is the tech stack. So I've used APS and ACC, Python and IFC OpenShell. HashiCorp Vault was used to store and access secrets. usbim.ids was to edit and create IDSs for the specific for the different projects. WEasyPrint was used to convert a HTML file to a PDF, and the whole app is run in Red Hat OpenShift, which is a Kubernetes-based platform. to build, deploy, and manage applications. Okay, so starting the app. I originally wanted to use the Webhook API and designed the whole app to be able to use it. But when I wanted to test it, it didn't really work as expected. The reason for this is that we have a really high security in Statnet. And apparently when APS wanted to notify me when a new IFC has been uploaded, we have an Iron Dome firewall that just shoots down the request since I'm not initiating it. So that didn't work. So I had to find another way to start the app. So the Webhook API would have sent a post request to the app. So that's essentially what I'm doing. I have created another deployment. The whole deployment is what you see on screen right here. It's only 41 lines and it has a really simple job. So if you zoom into the yellow box here, the only thing it does is to send a post request to the validator's address and then sleep for 7 days. This could be changed to 1 day or every 2 weeks. But yeah, every week is fine. And this then starts the app. Since I couldn't use the Webhook API, which would have given me the file and the location of it, I needed to find the files myself. So we have a project template, which looks like this. And the IFC files for each project are uploaded in the files with the IFC and the bracket around them. So that's where I find the IFCs. And I've also added to the template the folders inside the box. So that's where I would upload the BCF files, the PDF files, and where I would put the IDS for the project. So step number 3, I've tried to order this in a Python way. So if a function is under and indented, it's called in the one above. Okay, so the first function here. So all of the IFC files, I pull out the raw JSON for all of those files and send it into this function. I do the same with the PDF folder and the JSON and the IDS folder. So this function just really cleans up all the, call it mess, and what you are left with is something to. So function number 2 takes in the cleaned IFC array for all the files in the IFC folders, all the PDFs in the PDF folder, and in the latest IDS. And what it does is comparing the IFCs to the PDFs and the IDS to see if a file really needs validation or not. Because if I don't really want to download and validate files if that version of file has already been validated. So how I do that is, so every PDF is structured in this way, consisting of the IFC file and the version of it, the IDS file, and the timestamp. So if I then take one IFC from the IFC array, comparing it to the PDF with the same IFC file name, I could see if, okay, the first thing, does it exist? Is there a PDF? If there isn't a PDF, that means I need to validate it. If the version is different, I also need to validate it because there's been updates to the model. And again, if it's a new IDS. has the requirements changed. By checking these things, I would only download and validate the files that really that only the ones that need it. And then I only download them. So yeah. Step number 4 is validating them. So I go through and open the IDS and the IFC files using IFC OpenShell's functions. And just like this, the files are validated. I create a JSON reporter. So I turn the validation into a report, and this is mostly for my own sake to print it out in the logs. And I also create a HTML report. This will be used later and eventually be uploaded again. So at the bottom of the so we have a function called HTML reporter here, which I'll go through in the next slide. In addition to the HTML report, I also create BCF of all the errors in the validation. So now we're inside the HTML report, and we're going to generate the report. The file name is following the same template as with the PDF, just a different extension. And based on how many failed checks the validation had, I choose one of 2 templates. So now I've set the limit at 1,000, and this is essentially trying to reduce some of the PDFs in length. If there are a lot of issues, it could become unnecessarily long. So when I've chosen a template, I use PyStash to inject the results into the template. And then I'm converting the HTML file into PDF. So on this page, we have the 2 examples. So if we see the one to the right, we have about 600 errors. So that's under the limit of 1,000. And if you go down here, we can see that all of the objects with an issue are printed out. So here we have 2 objects with IFC site error. On the report on the left, we have over 7,000 errors. This report would be extremely long if we have done the same and printed out 1 line for each of the failed tests. So as you can see here and here, I'm skipping that part. Step number 6 is how to handle the BCF files. So we have done a check at the top. We have passed 153 out of almost 2,900, giving us about 2,700 errors. And that's a pretty big single BCF file containing 2,700 issues. Because of a limitation in ACC, I can't import this file to ACC to look at all the errors, because ACC has a limitation that you can only import 100 issues per BCF. How I solve this is by simply splitting up the BCF into smaller files, but that also has some negative sides, especially for this case. That would mean 27 different BCF files. So I'm not really happy or satisfied with this is solved right now, but yeah. Yeah, and I also forgot, in cases like these, with a lot of, where they would have been created a lot of BCFs, I've set a cap that, okay, if you're over 500 failed, I won't upload any BCFs. You would have, then you can just look at the report and find out, and yeah, you can fix a lot of errors by simply looking at the report. So the BCF folder wouldn't be overflooded with these files. So step number 7, you need to upload the files. So the files that are uploaded are the PDF and the BCFs. And so this is round 1 for each time. And what you do is firstly, you create a storage location for the specific project. Then you get a signed S3 URL. Then you upload the file to that URL. And then you complete the upload, but you're not really completed. You have to create the first version of the file, and then you would see the file in ACC. Step number 8, the result. So in the picture on the top left, we're inside the PDF folder. So there, all the PDFs of the validated files would end up. You could get a quick overview of the status of the validation. At the bottom left, we're inside the BCF folder of the project. So here you could look at the BCFs and you could import them into the model, as you can see on the right, showing you what objects are missing something. And you would, of course, by clicking at the issue, see what was wrong. Challenges, of course, we have some challenges. The first one is .NET's high security. The first thing so with the webhook API, that was a curveball. I didn't expect that, but you have to respect your company's security, and that's the only way to do it. So that was a bit of a bummer, not being able to use the webhook API. And the security was really the reason why we wanted to create this app by ourselves. We know where things are stored. We have the security internally, or we have the files internally, and it would be a pretty lengthy process to find another vendor, a third party, to solve the problem for us. The third party would probably be a cloud-based solution, which would make the process even longer. So we know that there are other third-party apps that do the same, but that's really the reason why. Challenge number 2 was with the BCFs and the issues. So when you import the issues in the model, as we saw earlier with the yellow circles or balls, a problem I faced was when I clicked one of the issues, my camera would zoom far away from the actual location, and it would happen to all of them. When I hit the home screen, I would still see that the expected object was highlighted, and I could see the issue info on the side, but there was something wrong. So on this slide here, you can see a high definition picture of an BCF. And if you have ever opened a BCF in a text editor, you get what I mean. So we have this topic tag, which is what you see when you click a BCF, containing the title, creation date, the author, and the description. But you also have some viewpoint tags. These are linking to other files again, .bcfb files. And if you go into those, here we have a lot of coordinates. And the problem was here. So on the left, we have an issue, issue from a BCF created by the IFC tester. And the X, Y, and Z coordinates here are using another Python package called NumPy. So it uses the np.float64 function wrapped around the actual coordinate. This is really no problem when your language, call it, is Python. But ACC didn't really speak Python, so it didn't understand what to do with it. So what I did was really just to remove this np.float64 for all of the coordinates, and that really worked. Okay, so the future potential and takeaways. I don't really have personal what do you call it, experience with an issue management database or server, but several on my team really think that that would be a benefit to just send the BCFs to a server or database rather than what we're doing right now, especially with the splitting up and stuff. Another thing is the BIM Execution Plan, or the BEP. I really think that should include an IDS of the requirements, and not only a PDF with the written requirements. This would benefit both us and the consultants because we know for a fact that these are the agreed upon data requirements that we should expect. The last thing is that you can't deliver unless the model has passed the checks. So let's say if you can't upload if you don't have 80, 90, 95% of the checks passed. And I personally have account admin, I have read, write, delete accesses programmatically. So I've thought about the idea of deleting the files that don't have X amount of checks passed. I haven't really done it, and I think I would be a popular man if that would ever happen. So for some takeaways, I hope you've learned some more about data validation, and it's accessible through IFC OpenShell, and I think it's cool. Take it from me. And some general thing is, it's really nice to abstract the problem from the user. In this case, only allowing them to see the results and interact in a program they know from before and not add another one. And lastly, I think programming is the future, or not the future, but is needed in the future of BIM. Thank you very much. You can contact me here and some questions. Thank you.